everyone, welcome back. We are on lesson 3-4 today, which is factoring the difference of two perfect squares, which you'll often refer me and other math teachers hear us refer to it as dots, difference of two squares. So first, let's think about some perfect squares. And I do want to point out, it says the difference, so it has to be subtraction. If you see addition, you cannot do these. So perfect squares, when you're talking about numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Go ahead and list the first, let's say 15 perfect squares, because if you can easily recognize them, it'll make the problems go a lot faster and it'll be a lot easier for you. So if you want, you can pause the video or do it along with me. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. All right, after that, 11 times 11, 121. 12 times 12 would be 144. 13 times 13 is 169. And 14 times 14 is 196. Finally, 15 times 15 is 225. Now, you can use your calculator to find that. All right, there's a couple different ways. So if you did, 5 squared, 25. 15 squared, 225. If you wanted to go the other way, so if you see one of these numbers pop up and you're like, oh, I don't know, I think 196. So the square root button and the squared are the same button. You just hit second x squared, and then you can type in 196. 14. Okay, so keep that in mind. As far as the numbers go, you want to be looking for perfect squares with these. These are all perfect squares. And then for the variables, you're looking for even exponents. So even exponents is what we're looking for there. And for exponents, we're going to just cut them in half. Whereas with numbers, like the square root of 196, we don't cut it in half, we take the square root. And again, that's just second x squared in your calculator. All right, so the first thing that we need to do is we need to make sure that we have difference of two squares, dots. So if you don't see a perfect square, if you don't see subtraction, then we can't do this. So step 1, do you see subtraction? And do you see two perfect squares? If those exist, then basically you're going to factor it out. Both terms, you're going to take the square root of both terms. And it's going to break up into two parentheses, just like we did before. So for example, if I have x squared minus 9, I see two perfect squares, so I'm going to break it up. All right, if I'm cutting x squared in half, it's just going to be x times x, 1 plus, 1 minus. And then the square root of 9 is 3, but again, if you weren't sure, second x squared, 9, 3. So these are called conjugates. They're exactly the same except for the sign. All right, that's what they're going to break down into. You could use your box for this, and you can even use the graph for some of these, because if I went to y equals and I typed in x squared minus 9 and hit graph, it crosses at -3 and 3, so it's going to be x plus 3 and x minus 3. All right, so it's similar to the trinomials we did before, but these are a little bit more specific. All right, so here you have two different squares. You have subtraction, so that's just going to break down into y plus 6 and y minus 6. And you can put the plus or minus first, it doesn't matter. All right, square root of 144 is 12. This is even and subtraction, so it's m plus 12, m minus 12. Next one's a little bit more complicated. Again, we're going to take the square root. We have two perfect squares and subtraction. So let's do the square root of the first term. 9x squared would end up being 3x. And then 1 plus 1 minus, and the square root of 4 is 2. So it's 3x plus 2, 3x minus 2. All right. Not a squared, but it is even. So remember, with that exponent, we're going to cut it in half. So it's a to the 5th plus, again, if you're not sure about 121, if you know your first few perfect squares, it's a little faster. So second x squared, 121, you'll see it's 11. So it's a to the 5th plus 11, a to the 5th minus 11. And that's it. All right. Let's look at a few more. This, it almost looks like it's m to the 4th plus 4, m to the 4th minus 4, but you can't have that plus sign. So this cannot be factors. Cannot be factored. All right. Because of the plus sign, it's not difference. It's got to be the difference of the two. All right, next one. Ooh, that's a doozy. Check the exponents. Even, good. Square root of 81 is 9. Square root of 25 is 5. And we have subtraction, so we're good to go. Whatever's before the sign goes as your first term. Whatever's after the sign goes after it. So that would be 9x squared. Because 9 times 9 is 81. X squared times x squared is x to the 4th. And then for the second part of both of those, it would just be 5y. So it's 9x squared plus 5y, 9x squared minus 5y. This one's backwards, but that's okay. Whatever comes before the sign goes first. So square root of 4 is 2, 2 plus or minus, and then the square root of x squared is just x. Done. Ooh, a fraction. Not a big deal. We can cut this in half. We have subtraction. All right, so it's c to the 5th, or excuse me, c to the 10th, plus, now when you take the square root of a fraction, take the square root of the top and the bottom, just 2/3. So it's c to the 10th plus 2/3, c to the 10th minus 2/3. All right, let's see if we've got, just a couple more, and we're set. All right, this one, I can't cut 15 in half. It's not even, so I can't factor it. I mean, you could have had the plus 8 minus 8, but there's no way to get that x to the 15th, so we can't do it. All right, last one. Fractions, that's okay. Just check everything. So you got an even exponent. You got subtraction. 16, 81, and 100 are all perfect squares. So let's start with the w squared over 16. Take the square root. It's w over 4 plus 81 over 100. Square root of 81 is 9. Square root of 100 is 10. And then it'll be w to the over 4 minus 9/10. All right, so again, it's just breaking those down into conjugates, one positive, one negative. You've got to have an even exponent. You got to have subtraction. All right, so I'd like for you to try on the next page, practice 4. All right, and you should be fine with all of these. I know that there's a lot, but it's just practice. You saw how quick and easy they are. So just try those. And then at the very bottom, factor each trinomial using box or a graph. All right, remember, if it's just x squared, put it into your graphing calculator and see where it's going to cross. But for this guy, you're going to need to do your box method. So use those steps. Remember, first term, last term, multiply, and you can use your calculator from there. If you need to, take a look back at lesson 3-2 for help. All right, have a great day. Stop in the math lab if you get stuck.